So the first example that we have is it says at a department store you purchase items with the following prices. So we have $13, $73, and $27. And it says that there's an 8% sales tax in your state, and it's applied to the subtotal. So it says, will the final cost be affected by whether the tax is added separately or it's all applied to the subtotal? So basically what that's saying, does it matter if we apply this 8% individually or if we apply it all at the same time? Will we get a different price? So the way I can write this out is an 8% increase in price is 1.08 as a multiplier, right? 1.08. So is it the same thing as 1.08 multiplied by the $13 plus 1.08 multiplied by the $73 plus 1.08 multiplied by the $27? So imagine you're making 3 different purchases. Or is it the same thing, or is it not the same thing as the 8% tax applied to all 3 at the same time? If you buy all 3 at the same time. So I'll open this up to you guys. What do you think? Does it matter which order that I apply these in? Are they going to be the same answer, or maybe a different answer, or so on?
It should not matter.
You're exactly correct. So it doesn't matter which order that you do it in. You're going to get the same answer. Okay? And I'm not going to work it out, but you will get the exact same answer. So what we're doing, what you can see is as far as the right side compared to the left side, all we're doing is distributing that 8% increase to everything in the parentheses. So we're just distributing the 1.08 to the first one, to the second one, to the third one, right? And if we do that, we're getting the exact same thing on the left side. Okay? So they're the exact same thing. It doesn't matter which order that you apply it in. Okay? So another example that we have, if we wanted to triple the recipe for chocolate frosting, we would need to triple each ingredient, right? So the way that they show it is they have 3 times each of the ingredients. So they distribute that 3 to each of the ingredients. Or that's the same thing as saying 3 times the first ingredient plus 3 times the second ingredient plus 3 times the third ingredient, right? So you could also look at it as just how I said it on the right side, where we have 3 times each ingredient. Or you could look at it on the on this side, and you can make the recipe once, right? So you could combine the cream, the chocolate, and the butter, and you could do that 3 times and then combine those in, right? So it's the same thing as making the recipe 3 times, or just combining 3 times the ingredients. Okay, so what we're kind of stumbling upon now is we call this the distributive property. And basically what that's saying is that whenever you have some number outside the parentheses and you're adding 2 things together or subtracting 2 things, you can just distribute that A or just multiply that A to everything that you're adding or subtracting together in a parentheses. Okay? So the example that they give is you have 3 multiplied by x minus 4. So we just distribute that 3 to the x and to the negative 4. So we get 3 times x, which is 3x, and 3 times negative 4, which is a negative 12. Okay? And we can do this with more than just 2 as well. So as an example that we'll get to in just a second, we can multiply negative 3 to 3 things, right? So let's do the first one. So we have 3 multiplied by 5h. So what does this simplify to?
$15H.
Yeah, 15h, right? Just simplifies to 15h. So we're distributing, in quotes, distributing this 3 to the 5h. So 3 multiplied by 5h. So on the next one, we're going to distribute this negative 3 to all 3 terms that we're adding and subtracting. So I'm going to multiply negative 3 there, multiply negative 3 there, and multiply negative 3 there. Okay. So what's negative 3 times x squared?
Negative 3x squared.
Yep, negative 3x squared. Negative 3 times negative 4x is a positive 12x, positive 12x. And negative 3 times a positive 1 is a negative 3. Okay. So all we're doing is just distributing that one number into all the terms that we have in the parentheses. Okay. All right, any questions on this first page? All right. All right, so we'll go on to the next page then. So this one, we can solve in two different ways. So what's the first way that we could solve this? Or what's one way we could solve this first problem?
Solve what's inside the parentheses first.
Combine what's inside the parentheses first, right? So that's one way we could solve it. The other way we could solve it is we can distribute this negative 4 into both of these, and we'll get the exact same answer. So let's do it both ways just to show that our intuition is correct. So we'll do combining what's inside the parentheses first. So what's negative 4 minus 7?
Minus 11.
It's negative, what, 11? Yeah. So we have negative 11 multiplied by negative 4. So we get a positive 44 here when we do that. Right? So we get negative 4 multiplied by negative 11. We get a positive 44. Right? Let's distribute this negative 4 and see if we get the same answer. So we have negative 4 multiplied by negative 4, which is a positive 16. And a negative 4 multiplied by a negative 7, we get a positive 28. And what is 16 plus 28?
44.
Yep, 44. Right? So we get the same answer either way. So now we're kind of starting to see that maybe there's more than one way we can solve things, right? So we could do it in either way as long as we follow the order of operations. We can either distribute or we can combine what's in the parentheses first. Okay, so what about the second one? So I have 10x and I'm going to distribute that to everything in here. So what is 10x multiplied by x squared?
10x cubed.
Yeah, so I'm going to multiply the coefficient, so 10 times 1, which is 10. And when I have x multiplied by x squared, I add the coefficients. So I have x to the first multiplied by x squared, I get x to the third. Okay. 10x multiplied by negative 5x, we get negative 50x squared. And then we get 10x multiplied by 6, we get 60x. All right, so that's good for that one, right? There's nothing else we can combine. So that's good for that one. The next one, it looks like I'm going to use the distributive property, but I'm going to do it twice, right? So I'm going to do this, so 4 times both of those, and 6 times both of these. So 4 times 3 is 12. 4 times negative 2i is negative 8i. And then I'm going to add to that 6 times 8. So what is 6 times 8?
48.
Yep, 48. And then 6 times negative I, we get a negative 6i. Right? Can we do anything else with this problem?
Bring the like terms together.
Yep, we can combine the like terms. So we get 12 plus 48, which is 60. And then we get negative 8i minus another 6i. So we get negative 14i. Yep, and then that's simplified as is. Okay. So the next one, we're going to do that again, right? So maybe this is getting a little repetitive at this point. So I'm going to distribute the 2x to each one of these, and then distribute the negative 5 to each of these. So I have 2x multiplied by 6x to the third, so I get 12x to the fourth. 2x multiplied by a negative 4x, we get negative 8x squared. 2x multiplied by 11, we get 22x. Okay, so that's the first one. Then we get negative 5 multiplied by x, which is negative 5x. And then negative 5 multiplied by 9, we get a negative 45. Okay. And now we can combine like terms, right? So the only ones that I see are just these two right here. So combine those two. So I'm going to rewrite the first two. 12x to the fourth minus 8x squared plus 17x minus 45. Okay. Any questions on those ones so far? Okay, so now we will step up the difficulty just a little bit. So this one says we've seen the distributive property can be used with mental math and with a multiplier over an expression that has two or more terms. Basically what that means is we've just been using this as a multiplier in front of each of these terms. Okay, so we can extend this idea of a distributive property to polynomial multiplication. So we can have one parentheses multiplied by another parentheses. Okay, and the way that we can do that is we have a few different ways. So I'm going to solve this multiplication in a few different ways. So we can't just multiply the first one with the first one here and the second one with the second one here. We have to do it in a special way. So the special way, we call this the FOIL method. So I'll show you this method first. So the FOIL method. And what the FOIL method is we multiply the first ones in each parentheses multiplied by the outer terms in the parentheses, multiply the inner terms in the parentheses, and then the last. So basically what that means, f is the first, so we have x times x, which is x squared. Then we do the outer, which is x times 3, which is 3x, so plus 3x. Then we do the inner I, which is 2 times x, which is 2x. And then we do the last, which is 2 times 3. Okay, so that is 6. Okay, and then we combine like terms. So we get x squared plus 5x plus 6. Okay, so this FOIL method only works when we have something plus or minus another thing multiplied by something plus or minus another thing. So we have two terms in each of the parentheses. Okay? So this won't work when you have maybe 3 terms in the first one and 2 terms in the second one, or something like that. Okay? So what if we want to do this in a different way that maybe is a little bit more intuitive? Okay? So what I'm going to do this time is I see I have 2 terms in both of these. So I'm going to make a box. And what I'm going to do is I'm going to make it a 2 by 2 box. So I'm just going to split this down the middle here and this here. So I have this box, right? And I have 2 here and 2 here, right? So it's a 2 by 2 box. And what I'm going to do is I'm going to fill in this x plus 2 up at the top here. So I'm going to put an x here, and I'm going to add that to 2. So I'm just going to omit the addition sign for now. I just want to worry about it's a positive 2. Okay. So this is x plus 2 at the top. And then I'm going to do x plus 3 over here on the left side. So I'm going to have x and 3. Okay. And what I'm going to do here is I'm just going to multiply whatever crosses the box. So I have this x that crosses over here, and then I have the x that crosses here. So this box right here is just x times x. So I have x squared. Okay. Then if I look at this box, I have 2 and x, so I get 2x here. Down here I get 3 and x, so I get 3x. And then I get 3 times 2 in this corner, which is 6. Okay. And then what I do now is I just add those all together. And hopefully you can see that this box right here, these 4 terms, are the exact same thing that I found up here. It's the exact same thing, right? And then all I need to do is just combine those to get this answer again. So this one we call the box method. And the width and height of your box just depends on how many terms you have in the first and second parentheses. Okay. Okay. We'll do a few more examples on the next page, but does anyone have any questions over these 2 methods so far? Okay. All right. So there's no questions so far, so that's good. So, so they actually wrote it on the next page too. So probably should have just turned the page, but I didn't see it. So this first one, they're multiplying each other, just like the FOIL method, right? So kind of like this one down here. So FOIL, it's just the product of the first term, so x and x, the product of the outer terms, the product of the inner terms, and then the product of the last terms. And then you can also do the box method down here. The first way that they showed it, I guess this is the one that I omitted. So what you can do is you can kind of split these up. So kind of like the associative property. So what I can do is I can say that this is x multiplied by x plus 3. And this is 2 multiplied by x plus 3. Or I guess they did it the other way, right? So we're distributing this x to both of these. And then we're distributing the 3 to both of these, right? So we're just kind of splitting this up, right? So you can do it that way as well. Personally, I like the box method better. I think that it orders it a little bit better, so it's easier to combine like terms and less prone to mistakes. So the preferred method for me is the box method. Okay, so we'll go on to the next page and we'll work through a few of these examples. Okay, so this first one here, what method do we want to solve this with? Do we want to do the first, the second, or the third method? So the box, the FOIL, or the distributive method?
Box.
Sure, so let's do the box method. That's fine. All of them will work. So let's make a box. And what size is my box going to be?
2 by 2.
2 by 2, right? Because I have 2 terms and 2 terms. So on the top, I'm just going to put the first one, and it doesn't matter, right? We can switch the order of these. That's the commutative property of multiplication. So I'm just going to do the first one though. So I have x and -2. And I'm going to put a negative here just to make sure that I know that this is a -2 since we're subtracting. And then the same thing on the left side. So I'm going to do x and -8, right? And now I can just combine these, right? So what's the top left box going to be?
X squared.
Yep, x squared. What about the top right box?
2x.
-2.
Minus 2x.
Yep. So -2x. The bottom left is going to be -8x. And then the last one's going to be +16, right? So one benefit of the box method is that we kind of see these diagonals form. And you'll see it better maybe with the next example. But we have this diagonal here. So if I cross through it like that, that whole diagonal is going to be all x squared terms. And the next diagonal is going to be all of our x terms. And the next one is going to be all of our constant terms. So as you'll see, like maybe with the next example, we're going to get these diagonals that we can add together to combine our like terms, right? So we start with the x squared. So we get x squared. -2x minus 8x is -10x. And then we have a +16. So we're just going to add 16. Okay. So that's our answer for this one right here. Okay. Anyone have any questions on that one? Okay. All right. So what about the next one? What method do we want to use for the next one?
I would say box, but because there's 3 terms in the second set of parentheses, would we not be able to use the FOIL method with that?
Yeah, so the FOIL method only works on something like this one up here, where it's 2 terms multiplied by 2 terms. So this one, we actually only have 2 choices. And the box method is definitely going to be the easier of the two. So let's do the box method. And what size should my box be?
2 by 3.
Yeah, 2 by 3, right? So I'm going to make a 2 by 3 box. And where does the x plus 1 go? Does it go on this side, so on the left side, or on the top side?
On the left side.
Yeah, it's going to have to go on the left side because this is the only one that has 2 terms, right, or 2 spaces. And then the x squared minus 2x plus 1 is going to have to go on the top. Right? And then now we can just multiply each of the boxes, right? So the top left, we get x times x squared, which is x to the third. X squared multiplied by negative 2x is negative 2x squared. Then x times 1 is x. Okay. And then one special thing that I notice on this bottom row here is I have 1 times this, 1 times this, 1 times this. And 1 times anything is just itself, right? So I can just rewrite this one, this top part, the x squared minus 2x plus 1. And I can just rewrite that in the box down here. So I have x squared minus 2x plus 1, right? And then we notice that diagonal that we were talking about up here, right? So this first diagonal, I have all my x to the third power. So I have an x to the third. My next diagonal, I have all my x squareds. So I get negative x squared. Then in my third diagonal, I get negative 2x and x, which is a negative x. And then finally, I have a positive 1. So I should end up with x to the third minus x squared minus x plus 1. Okay, so now that I've done that, maybe we'll have a little bit of a harder problem now. So the next one says, each of the following problems uses a box method of multiplying polynomials. So it says fill in the missing terms outside the box or inside the box, and then write the area as a product and a sum. So basically what we're doing is we're given partial information. In this partial information, we're going to use to kind of fill in the rest of the boxes, okay? Okay, so let's say, is there anything that I can fill in this first box? Like maybe up here, maybe on the left side, or maybe these two boxes?
Top left will be x.
Over here?
Both of the tops will be x.
Well,
There.
up here is going to be an x?
Mhm.
Sure.
And then to the side will be an x.
Yeah. Right, because x times x is x squared. Yep. So what would this box be then, this top right box? So this top right box.
3x.
Yep, 3x. And do we know what this bottom right box is?
4.
4, okay. So what do I need to multiply 3 by to get to 4?
Oh, I don't know. Sorry.
Right. Yep. Okay, so that's incorrect, right? So maybe we can't fill in this box yet, but maybe we can fill in what's over here, right? So what should go right here, the second term? Well, we know that what is it?
1.
1? Well, we know
Negative
that
1.
no, not necessarily, right? Because we know that we have to have x times something, and that's going to have to equal 4x, right? So what times x equals 4x?
4.
4, right? So we're going to have 4 here. Right? So 4 times x is 4x. And now we can fill in this last box, right? So we have 3 times 4, which is 12. So what we can do is we can write this as a product first. So if I wanted to rewrite this, I would have x plus 3 multiplied by x plus 4. Right? So I'm just rewriting what's at the top and what's over here. So I have x plus 3 times x plus 4, and that's equal to just whatever's in the box, right? So we have x squared plus 7x, right, if I combine the x terms, and then plus 12. Okay, so that's good on that one, right? So we wrote it as a product and we wrote it as a sum. So product, sum. Okay. What about the next one? So I have 3x on this side, so I have maybe my one term, but I don't have the 3 terms across the top. So let's go backwards. I think this is going to be a little bit simpler. So 3x multiplied by what equals 15x? That's what I had to
5.
multiply. 5, right? So 5 times 3x is 15x. So 3x multiplied by what equals negative 3x squared?
Minus X.
Yep, just a minus x. Yep. And what about 3x multiplied by what equals 6x to the third?
2X squared.
Yep, 2x squared. Right? So we multiply the coefficients, we get 6. X times x squared, we get x to the third. Okay. So let's write this as a product and then write it as a sum. So our product is 3x multiplied by 2x squared minus x plus 5. Right? So that's that multiplied by everything up top. And that's equal to, and I just rewrite what's in the boxes, right? So 6x to the third minus 3x squared plus 15x. All right, so I've done that, and now I can do the last box, right? So the last box, what do we want to fill in first? Do we want to fill in one of the boxes, or do we want to fill in what's up here?
The top left is going to be x squared.
So why is it going to be x squared? And you're talking about the box, right?
Yeah. No. On top, right here.
Oh, up here?
Yeah.
Okay. So how do you know that's going to be x squared?
Because these are already squared, so the x times x squared gives you x cubed, or x whatever, to the
Yeah,
third
x-
power.
Yeah, that's the same thing, yeah. So how do you know that's going to be x to the third then? So what kind of proof do we have that this is x squared up here, right? Because we're kind of making a term or making an assumption off of another assumption. So how do we know that this first one's true?
Because it always goes down, just the way the box always is, the highest is always in that corner, then the squareds, then the regular x's, and then the whole term.
Sure, but what's stopping this one from being x to the third power? So why can't I have x to the third power up here and then go to 2x, right? If it's still greater than this power over here.
I don't know.
Okay, that's fine. Yeah, so I agree with you that it's x squared. And the reason that it's x squared is look at this term right here. I have 1 times something equals x squared, right?
Mhm.
And the only thing that I can get to x squared by multiplying by 1 is x squared, right? Because anything multiplied by itself is itself. Yep. Yeah, so x squared has to be on the top here. Yep, I agree with that. And then, yeah, so then after that we can fill in this, right? So x times x squared is x to the third. Yep, so I agree with that. What's the next thing that we can fill in? We still have 2 boxes and then whatever's up here.
5 is up top.
Yep, 5 is up top, right? 1 times something equals 5. It has to be 5. Yep. Okay, so then we have x times 5 equals 5x. And we have 1 times 2x, which is 2x. Yep. Okay, and now we can write that as a product and a sum. So my product is, let's see, x plus 1 multiplied by x squared plus 2x plus 5. So just taking the top and the side. And that's equal to x to the third plus 3x squared plus 7x plus 5.